Okay, let's pick up where we left off. We're on problem 7 here in section 4.5. We're going to determine the horizontal asymptote of the graph. Now, if we want to find the horizontal asymptote, we should go back up maybe to our rules about horizontal asymptotes. And what we need to do is look at the degree of the numerator and the denominator. The degree of the numerator is 2, the degree of the denominator is 4. Since the degree of the denominator is bigger, y equals 0 is our horizontal asymptote, and that is it. Okay, problem 8, they want us to find the horizontal asymptote. And you'll notice that for horizontal asymptotes, we only have two options. Either the degree of the denominator is bigger, or the degrees of the numerator and the denominator are the same. That is not the case here. The degree of the numerator is actually bigger in this case, and it's 1 bigger than the degree of the denominator, so that actually means that we're going to have an oblique asymptote. They're not asking us about that. They're asking us for a horizontal asymptote, and there is none. So we're just going to answer that question and move on. Let's determine the oblique asymptote of this function. So as you can see, the degree of the numerator is 1 greater than the degree of the denominator in this example, 2 versus 1. So the way that we actually find our oblique asymptotes is we have to do long division. So I'm going to go ahead and do it. I'm going to put the x squared plus 4x minus 5 in here. I'm going to put the x plus 3 in here. And as we always do with polynomial long division, we're going to ask the question, what do we multiply this x by here to get x squared? The answer is going to be x. If we take that x and we distribute it through the divisor, we get x squared for the first term, 3 times x, or 3x for our second term. We're going to subtract, and when we subtract, the x squareds cancel. That was the idea. The 4x minus the 3x just gives us a regular 1x, and we're going to bring down the next term. That's a minus 5. Now, one more time, we're going to ask the question, what would we multiply this x by to get this x right here? Well, the answer to that question is 1. So what we're going to do is we're going to put a plus 1 up here, and we're going to distribute that 1 through the divisor. 1 times x is x, and 1 times 3 is 3. We put that down here, we subtract, and notice what we get. We get negative 5 minus 3. That's a negative 8 as our remainder. Now, as far as oblique asymptotes are concerned, we don't care about the remainder, we care about the quotient. This quotient up here was x plus 1. Put a y equals on that thing, that is the equation of a line, and that is the equation of the oblique asymptote for this graph. So in here, I'm going to put y equals x plus 1. That is the equation of the oblique asymptote. Okay, let's move on to the next problem. Let's do it again. Let's find the oblique asymptote for this function. And I'm going to move this thing up so we can make some space. Again, notice that we do in fact have an oblique asymptote because the degree of the numerator is 4 and the degree of the denominator is 3. The degree of the numerator is 1 bigger, so we have an oblique asymptote. To find that oblique asymptote, well, we're just going to have to use polynomial long division. Probably the best way to do this is to write out each descending term for x regardless of whether it shows up in the polynomial or not. We're basically making space for our polynomial long division. I'm going to do the same thing with our divisor, though it may not be quite as necessary. And okay, let's ask the question, what would we multiply by 5x cubed to get 5x to the 4th? And the answer is x. We're going to take that x and we're going to multiply it through the divisor, and we can put that result down here. X times 5x cubed is 5x to the 4th. We're going to have a 0x cubed. X times 0x is 0x squared. Again, these are just placeholders. And x times 10 is 10x. Now we're going to subtract. And when we do that subtraction, you'll notice that the 5x to the 4th cancel. That was the plan. And the only term you actually get here is a negative 10x. We're going to bring down the next term. That puts a negative 2 down here. And one more time, we're going to ask the question, what would we multiply this 5x cubed by to get negative 10x? Well, the answer is there isn't anything. We're basically at a point here where what remains down in our long division problem has a degree that is less than our divisor. If that is the case, then we are done and this is the remainder. And since when we're finding asymptotes, we don't care about the remainder, we just take that quotient, set it equal to y, that is the equation of a line, and that is the equation of our oblique asymptote. And okay, why don't we stop this video here? We'll break this first section into 3 parts to keep them small, because in this next problem we're going to move on and talk about x-intercepts and y-intercepts, and I'm going to have to give you some notes on that. So I will see y'all in the next video.